A physics-first analysis for energy accumulation and amp. Architectural electrodynamics. 1. What is being claimed? Stripped of narrative. From the transcript. The technical claims are: copper dome segmented into electrically isolated sections, ceramic or insulating separators between segments, vertical copper conductors routed downward foundation level, earth contacts, with insulated junctions, annotations showing frequency, capacitance, voltage. Explicit note: function not decorative. Importantly, none of these components are inherently impossible, but none automatically imply net energy generation, so we proceed like engineers, not debunkers or believers. 2. Known physics that do support parts of this. 2.1 Atmospheric electricity is real. There is a vertical electric field between the ionosphere and Earth. Fair weather field. Approximately 100 to 300 volts per meter. Thunderstorm gradients. Orders of magnitude higher. Global atmospheric current. Approximately 1 to 2 picoamperes per square meter. This field can be harvested, but power levels are normally very low. 2.2 Copper domes as large conductive surfaces. A dome acts as a charge collector, has high capacitance due to area and curvature, is naturally exposed to wind ionization, precipitation, charge transfer, corona effects at edges. This is why church domes, spires, lightning rods were historically linked. 2.3 Segmentation changes the physics. This is the most interesting part. Segmenting a conductive surface with insulation turns it into a distributed capacitor array, potentially a slow RF, ELF resonator, a charge storage structure. Not just a conductor. This is absolutely valid electrical engineering. 2.4 Vertical rods plus ground equals dipole system. A vertical conductor from a charged structure to ground creates a capacitive coupling, a current path for displacement current, a way to sample atmospheric potential differences. This is essentially a passive electrostatic energy extractor similar to early atmospheric experiments. Kelvin water dropper. Lord Kelvin electrometer. 3. What this system could do. Realistically, 3.1 What it can do. Checkmark accumulate static charge. Checkmark act as a large capacitive reservoir. Checkmark smooth atmospheric electrical fluctuations. Checkmark possibly power electrostatic instruments, spark gap experiments, slow discharge lamps, sensors, early telegraph relays, clockwork triggers, ion wind devices. Checkmark function as a passive electrical infrastructure layer. 3.2 What it cannot do. Without extra inputs, power cities continuously generate kilowatts from fair weather fields, violate conservation of energy claims of 50 to 200 W. Continuous output from passive atmospheric collection alone would require storm conditions, forced airflow, active ionization, mechanical assistance, or energy storage charged by other means. 4. Why frequencies and amp capacitance might appear on blueprints. This is critical. Engineers do not write frequencies unless dealing with resonance, alternating fields, oscillatory discharge, mechanical electrical coupling, ELF, ULF modes. Possible interpretations. 4.1 Resonant charge pumping segmented dome plus vertical rods could act as a slow electrostatic resonator tuned to Schumann resonances, weather-driven field oscillations, wind-induced charge modulation. 4.2 Displacement current experiments. Even without net conduction current, changing electric fields create displacement currents. This aligns perfectly with Tesla's later ideas, Maxwell's displacement current term, capacitive single-wire transmission concepts. 4.3 Lightning and amp surge management. The system may have been designed to distribute lightning charge, prevent destructive arcing, safely bleed energy into ground, store and dissipate energy slowly. That alone would justify segmentation. Ceramic separators, insulated ground junctions. 5. The architectural angle. Very important. From a city-scale engineering standpoint, this system could be a passive atmospheric interface, a building-level electrical buffer, a static discharge stabilizer, a sensor network, an early form of electrical hygiene. Think of it as infrastructure that interacts with the environment electrically, not a generator. This fits perfectly with your vision of cities as energy-aware organisms. 6. Why this knowledge might have been lost. No conspiracy required. Reasons include shift to steam and amp Combustion rise of centralized generators, difficulty measuring low current electrostatics, fragility of insulating ceramics, lack of semiconductor rectifiers, no efficient storage electronics. Without modern diodes, capacitors, and measurement tools, these systems would appear mysterious, fragile, and non-scalable. 7. How we would test this today. Actionable, experimental replication protocol. Safe and legit, scale model 1 to 2 meters, copper domed segmented panels, ceramic spacers, vertical rods to earth ground, instrumentation, electrometer, FA/Na range, high impedance voltmeter, NGT, 10 squared omega, data logger, weather station, RF spectrum analyzer, ELF KHC. Experiments, static charge accumulation versus weather, segment to segment voltage differentials, displacement current during field changes, spark gap threshold measurements, coupling to flywheel or spring-loaded electrostatic motors, outcome, quantify what it really does, no belief required, publishable results either way. 8. How this fits into your energy framework. This belongs in your book as case study category, architectural electrostatics and amp. Environmental field coupling. It complements atmospheric harvesting, displacement current research, passive energy buffering, long life infrastructure, zero maintenance electrical interfaces, not a miracle generator, but a missing layer of environmental engineering. 9. How I recommend we frame it publicly. Avoid free energy, lost civilization, powered cities, absolute wattage claims. Use instead passive atmospheric electrical systems, architectural electrostatic accumulation, pre-industrial field coupling, engineering, environmental charge management. This keeps the work credible, investigable, and expandable. Global Robotics Corporation.